Hi everyone, this video is for Engineering Economy on the 29th of August 2019. Hopefully you got the message that this lecture is going to be delivered on YouTube. I'm out of the country right now, and so it's just this one lecture that we'll have recorded as a video. We'll be back to our regular schedule in the normal classroom location at 8 a.m. on Tuesday, September 3rd. A couple of other announcements. The lecture notes are available on MU Online. You should have already received an email that also mentioned the same thing. There's a variety of different formats if you want to print out 1 slide per page, 2 slide per page, 3, etc. So you choose whatever looks best to you and what is the right size for the prints that you'd like to do. Also, it's important that you purchase or rent the textbook as soon as possible. Although the homework assignments this semester are going to be ones that I put together, so you're not going to need the textbook for the homework assignments, you are going to need it for a lot of the concepts and to reinforce the learning that you need to do, the reading. So it's the 7th edition of Engineering Economy by Blank and Tarquin. It should be available for a very low price since they've moved on to other editions, and so I think it's extremely affordable, and there's really no reason for you not to get the book. It's great. One other announcement before we begin. Homework number 1, your first assignment having to do primarily with interest rates. That assignment is due on Thursday, September 5th at 8 a.m. So that's going to be due after I'm back from my trip, and so that you can come see me in my office if you've got questions or if you need a little bit of time to double check on things before you submit it. Like all of our submissions, this assignment for homework assignments, that needs to be uploaded to MU Online as a single PDF file. So that means don't do multiple PDF files, one for each page. Don't do that. Also, don't upload JPEG files or TIFFs or any other format besides PDF. It has to be a PDF, and it should be uploaded to MU Online before class on Thursday, the 5th of September. There's an app called Cam Scanner that's available for both iPhone and Android. I'll try to remember to demonstrate that in class on the 3rd. But if you want to get an early start on that, it's really easy to operate. And when you get into that, please set your file scanning settings to black and white. It provides a much better image quality than if it's grayscale or color, so black and white. So I'll try to remember to go over that in class on Tuesday the 5th. So the subject of today's lecture recording is interest rates, rate of return, and cash flow diagrams. The bulk of this lecture was previously recorded in a prior semester, and so there may be some incidental references to time that don't quite match up with what you've heard in the announcements here. Just rest assured that the things that are on the screen here, the announcements that I've given you via email, and the schedule that's available on MU Online along with the syllabus, all of those are the dates that apply. And so if there's just some stray comment about a Wednesday or Friday or something in the lecture, you can just ignore that. It's really the content that applies here. So if you have any questions, please feel free to send me a message, and I'll do my best to respond. Since I'm going to be out of the country with a big time zone, time difference between here and there, it'll be a struggle for me to respond maybe as quickly as I generally would like. But if you do have an urgent issue that can't wait until I'm back, feel free to get in touch and I'll do my best. All right, with that, we'll get into the lecture, and I'll see you in person on Tuesday, September 3rd.
How many of you have ever borrowed money before? A lot of you are borrowing money for school, right? And that can really add up quickly. And so you may have already had a first exposure to interest, but let's begin by discussing some terminology here. And specifically, we're going to focus on perspective, like the perspective of the person who's loaning the money and the perspective of the person who's borrowing money. Now, interest rate can be thought of as the annualized percentage of the privilege that's paid for borrowing money. And so if you've got a borrower who's taking a loan, what they have to give back is the repayment of that original principal, which is the original amount that was borrowed, and interest. But from the perspective of the person who's investing or loaning the money, sometimes we call it the rate of return rather than interest rate. And the formula is the same. If you want to calculate the numeric interest rate, you can use the same formula that you'd use to calculate the rate of return. It's just that when you're the person who's borrowing the money, you think of it as the interest rate. whereas when you're the person loaning the money, you think of it as the rate of return. So it's a matter of terminology. Now, interest is a manifestation of the time value of money. And this is probably the biggest concept of the whole semester, time value of money. The idea of the time value of money is that money in the future isn't as valuable as money today. And so think of it this way. What if I offered you $1,000 now or $1,000 in 5 years? Which would you take? Most people would take $1,000 now, unless they kind of don't trust themselves and they want to delay gratification. But most of us would recognize that it's better to have the money now. And it's not just because of immediate gratification. There's actually a rational reason besides just like, not wanting to wait. Think about prices of things over time. Have your parents ever gone over that with you about like how much a candy bar cost in their day, or a gallon of gasoline was 78 cents, that sort of thing? You've heard that, right? Everybody's heard that. And so what that's talking about is how prices always seem to be increasing. So now that $1,000, if I give you $1,000 now, you can buy a lot of stuff. But in 5 years, you won't be able to buy as many things because prices are always going up. So if the amount of money is the same now and in the future, the value of what you can buy in the future is lower. So that's kind of the first exposure to this idea, time value of money. And we're going to come back to this a lot of different times. But interest is how we overcome the hesitancy that someone would have to loan you money that isn't going to be worth as much in the future. Because what if, we all know that the $1,000 in 5 years isn't worth as much. So think about a bank. If you went to a bank and you said, I'd like to borrow $1,000, and in 5 years I'm going to repay you $1,000. That would be bad from their perspective because they know that same number of dollars isn't going to buy as much in the future. So you have to kind of incentivize them to loan you the money. And the way that you incentivize is that you pay back more than you originally borrowed to account for the time value of money. So you can think of it as the fee that you're paying to use someone else's money. You can think of it as, from a numerical standpoint, interest is a dollar amount, and it's the difference between the ending amount and the beginning amount. So the amount you borrowed and the amount you pay, the difference between the total amount and the initial amount is the interest. Amount owed after some time minus the principal. And the principal is the beginning amount of a loan. Now, I see many of you taking notes. That's a really good habit. By the way, these notes are going to be posted on MU Online for the entire semester at the end of today. So you'll be able to print out all of the notes in any format that you like, because what I do is I post them as full page, so like 1 slide per page, 2 slides per page, 3, 4, and 6. And so if you really want to cram a lot of information onto a single page, you can do that. If you want to have some space in the margins to write your notes, you can choose whichever format you'd like. I wanted to have that posted before class today so I could show it to you, but I just ran out of time. So I'm glad you're taking notes today, and on Wednesday maybe what you can do is print out all those notes and put it in a binder and then copy down your thoughts adjacent to the slides themselves. Okay, so interest rate is when we express the interest amount in terms of an elapsed time. So it's a percentage of the principal during an increment of time. So here's the formula for that, for the interest rate. It's the interest accrued per time unit. So that's a certain amount of interest that you're going to be either earning or paying during a time unit. And the most common time unit would be a 1-year period. Interest rates are very often expressed in terms of an annual percentage rate. And then you divide that as a fraction of the original investment amount, the principal, and multiply it by 100, and that's interest rate. Now, rate of return, same formula. It's some incremental amount divided by the original amount, in other words, divided by the principal, and you multiply it by 100 to turn it into a percentage. The borrower thinks of it as an interest rate that's been paid. The lender or the investor thinks of it in terms of a rate of return. Okay, one other way to look at it is the amount that's due at year one is the initial loan amount plus the initial loan amount multiplied by the interest rate. And the reason why I put that formula on the screen is I'm going to give you an in-class exercise, and that's another way that I do things is I don't want to get up here and just talk for 50 minutes because I've been teaching now, this is my 14th year teaching college, and I've learned that the less I talk, the more you learn. Right? That's unfortunate, but I'll try and give you a little bit of a lecture, and then I'll give you some in-class exercise where you can apply and kind of practice out these equations and ideas so that the thinking is that when you get to the homework assignment, you're not like lost. You've already done a bunch of problems that are related to the homework assignment, and it makes it easier to kind of get into it. And then the homework assignment prepares you for the quiz. And once you've had the experience with testing your knowledge in the quiz, then you're ready for the exam. So I try and make that transition like gradual and progressive so that everyone feels comfortable along the way. So we'll do these in-class exercises every class meeting. I'll have 44 of them. And that's another reason why I think it's a good idea for you to have a 3-ring binder, is that these will be punched out, and most of the time you'll take it with you and you can use it as a resource to solve the homework. Sometimes I'll take it with me, and I'll give you points for participation. Those will go into your homework grade. And today, for instance, you'll notice that at the top of the page I'm asking you to write your name, and that's because before you leave the classroom, I'd like you to put your paper on this chair on your way out, and I'm going to record everybody who's here today and everybody who gives it their best shot on the in-class exercise. You're going to get some homework points for that. Now these, I encourage collaboration and teamwork on these in-class exercises. You know, all the stuff I said about you need to work alone, that's really for the homework and obviously for the exams and quizzes. But these in-class exercises, once I turn you loose to work on these, it can get noisy in here. You can talk to each other. It no longer has to be like quiet as church once you're working on the in-class exercise. In fact, I kind of like it when things get a little bit rowdy because I think that's an indicator that you're learning if you're actually discussing. So there's 3 problems here. We've got about 15 minutes, and I think that's the perfect amount of time. And at the end of that time period, I'm going to bring the solutions up on the screen just to make sure we're all on the same page. Did everybody get a copy of the in-class exercise? Okay, I've had 1 and 2 up on the screen already. So for problem 1, the total amount at the end of the 1 year is $21,000. Pretty easy there. You know, how much is the principal? How much is the interest? So $20,000, that's what we call the principal. The interest is the payment you give as a thank you to the bank for the privilege of borrowing that for the 1-year duration. 6% is because what we're doing is we're saying it's the interest amount, so the increment of interest divided by the original $200,000. Now on this third problem, there's 2 steps, and it doesn't matter which one you do first. I started by the currency conversion and then did the time value of money conversion. You can flop it and get the same thing. So first of all, I said if you have 55,123.45 Icelandic krona, how many United Arab Emirates dirhams do you get? So you divide by 35.25 krona per dirham, and you get 1563.79 AED. And that's the final value. That's today, 1 year later. What we want to know is, what was the equivalent number of dirhams at the beginning? And so the conceptualization of that is the amount at year one after interest has been added in. It's the initial amount, so the principal plus the interest. And the interest amount is the principal times the interest rate. So this second term here is the interest, which is principal times interest rate. So in the end, you should get 1518.24 AED. I'm going to ask you to consider, for the interest rates that are shown up on the screen, and I'm also handing out the paper now, why is it that maybe one rate is higher than another? Why is it that certain interest rates seem to be extremely high? Maybe some of you have already borrowed money, like student loans, or maybe some of you have credit cards and have felt the bite of credit card interest. But for this one, questions A through E, I'd like you to go ahead and collaborate with your classmates, come up with some critical thinking, short answers to each of these questions. Now, I have to warn you that this semester you're going to do a lot of calculations. It's an engineering course after all. But at the same time, a really important part of this course is being able to explain and understand the reason why. And the reason why I feel that's important is that you're going to be more than just a technician. You're not going to just be plugging numbers into formulas that you're given and calculate away. You're not a calculator operator, but engineers have to understand the fundamentals. And one of the best ways to learn the fundamentals and to assess them is through explaining concepts. And so short answers like this will be on almost every quiz. They'll be on every exam. So it's important for you to take the ability to answer questions seriously. And so don't just give one-word answers, is what I'm getting after here. Really try and be as thoughtful and detailed and at the same time concise as you possibly can. So I'm going to pause the recording, give you some time to work individually on this. Do you have a question? Oh, you guys need a few? All right. Are there extras on this side? Yeah, I don't count them out before I put them down each row, but we've always got plenty. Thank you. All right. So go ahead and discuss amongst yourselves. Please put a good response on the paper, and then we will revisit the answers together. All right. Let's talk about this table. Now, first of all, remember in the first lecture on Monday, we talked about how one of the reasons why interest is charged is to account for the time value of money. And you're going to hear that phrase, time value of money, a lot of times this semester. Can anyone briefly just remind us what time value of money is all about? Yeah.
Money that you borrowed today
Mm-hmm.
is worth more. You can buy more with it, whereas money in the future, because things increase in price,
Yep.
you might not be able to buy the same amount of things with the same amount of cash. So interest is used to account for that.
Exactly right. Very good. That's an excellent explanation. So what he said is the money that a certain number of dollars today, whether it's 100 or 1,000, a certain number of dollars today can buy more stuff than it will be able to buy in the future because prices are going up over time. And so if you're taking money from someone today, those dollars that you're taking are more valuable than the dollars you're paying them back with. And so naturally they're going to want more of them if each individual dollar isn't worth as much. So that's part of what's going on with interest. Now, on question A, it asks, why is the savings account rate the lowest? And we'll start off by, these are all products, as they're called, by a bank. But one of these products is different from all the rest, and it's the savings account. How is the savings account product different from all of the others?
We're making money opposed to them making money.
Exactly right. And so it's different from all the rest because in the case of a savings account, you, the individual, are giving money to the bank. And so you're the investor and the bank is the borrower. And so in the case that the bank is the one who is going to be paying you, what do you notice about those interest rates? It's the lowest. And so naturally, they don't want to pay you more than they're going to be earning on the loans that they give out to other people. Because essentially what they're doing is they're taking the deposits from their depositors, and they're using those deposits in the loans that they make to other people. And so how do they make their profits? It's the difference between the two. They borrow the money from you for very little, and they take those same dollars and they loan them out to someone else for a little bit more, and they keep the difference. And so the first thing we see in question A, what I said, why is the savings account rate the lowest? The way that I put it is because with the savings account, the bank is paying the interest. So it's a matter of perspective. In that case, they're the borrower, and when they get to call the shots by saying what the interest rate is, they'll have that be pretty low. It's really hard to get ahead today if you're the one who's loaning money to banks. Savings account rates are kind of lower than they've been in a long time. Okay, question B. Have you ever heard of a CD before? Does anybody know what that abbreviation CD stands for? Certificate of deposit, that's right. And so what is a certificate of deposit?
Basically how I understand it is it's a deposit you give into the bank and you keep it there and it accrues interest.
Uh-huh.
And you can take it out whenever you want, but there's fees, and you can borrow against it and use it as a secured loan.
Okay. I think you're right. Certificate of deposit is a fixed term deposit. And so the person who's putting the money in actually can't take the money out anytime. I mean, you can, but then you have to pay a penalty. And so it's different from a savings account because a savings account, the depositor can take the money out at any time with no penalty. In a certificate of deposit, what's not listed here is often a bank will have a 1-year CD, a 2-year CD. And so at the beginning, when you're first putting the money in, you tell them how long you plan to leave it there. And it's advantageous to the bank because then it gives them a little bit more flexibility in how they use it. They can take CD money and make a longer term loan with it because they know that it's not going to be, someone's not going to come in asking for their money back right away. So because of the additional flexibility it gives to the bank, they pay slightly higher interest rates than for a savings account. So that's the essence of question B. Now C, I'm interested to know what are your thoughts on why might the mortgage rate be higher for a 30-year loan compared to a 15-year loan? Why is it that a bank wants you to pay 4.29% for a 30-year mortgage loan, but would only charge you 3.50% for a 15-year mortgage loan? Why do they demand more for the longer term? Okay. Change in value of money. All right, well, let me play the devil's advocate here. But they're already getting interest the same, like they could have just charged 3.5% over 30 years. Why does it have to be more for the 30-year term than it was for the 15-year term? Because they're already getting some money back. Okay. That's a good question.
They want to make more money off of you?
Oh, they always want to make more money. You're absolutely right, yeah?
It's a greater liability for them to get a few for 30 years and 15.
Why?
Because whenever they don't have that money for half as much time, they don't have as much they can give out and make from.
Okay.
It's more liability for them to give you a 30-year loan that you may not pay all.
You're saying that they're making a long-term commitment. Yeah, sometimes you want more when you're making a long-term commitment.
Someone could suddenly lose their job 20 years down the road. In 15, they'll be fine because they've already paid it off. And 30, that's 10 years of not having their career.
Okay. What was your idea?
I think if the same amount of money is distributed between 15 and 30, you pay less for 30 years.
Yeah, each monthly payment is lower. Yeah.
And because of that, the money you pay actually is like you pay the exact same money at the future, so you have like less worth of that money.
I see. Those are all really good ideas. I think that we could distill all of them consolidate them into one word, and that is risk. When a bank makes a loan, they're taking on some risk because they just gave you a big pile of money and they've got their fingers crossed that that's going to come back to them. And so a 30-year mortgage is more risky to a bank than a 15-year mortgage. And there's a variety of reasons why it's more risky. It may be that employment is less guaranteed over the long term, because in 30 years the robots are going to have us all out of a job, right? But another big factor of it is think about time value of money. How much is a dollar going to be worth in 15 years? That's not scheduled. I mean, we don't know in advance. Predicting the future is very uncertain. We can look into the past and we know what inflation was over the past 15 years or the past 30 years, but we don't know what it's going to be in the future. And in the future, there's more risk for the bank over a 30-year time frame in terms of how much inflation there might be. And here's a really bad thing for the bank. It's bad if they're only charging you 3.50%, but then inflation goes up to 4%. So that means if money is losing its value more quickly than they're getting interest back, then what that means is that the purchasing power of their dollars is actually decreasing. And I know there's some new terms there and it's a complicated idea, but just think of it this way. What if you were making a loan to a friend and you said, all right, I'll give you $1,000 and you have to pay me back $1,100 in 1 year. But suddenly the economy went crazy and now it costs $2,000 to buy a loaf of bread. I mean, you've heard about countries where that happens, right? Zimbabwe, I think it's happening right now in Venezuela, hyperinflation, where you have to take a wheelbarrow full of money to the grocery store, that kind of a thing. Well, when there's lots of inflation, then the money doesn't really buy as much as it used to. And so if you have just loaned out a bunch of money and the people can pay you back with worthless wheelbarrows full of money, then you're in big trouble. And so risk, the main thing I said we could boil it down to risk. There's more risk for the bank with a longer term loan because there's a possibility that the value of money could erode faster than they are recovering it back from the borrower. So we'll come back to these ideas again. These concepts are complicated, but I did want to point out that the one word that can explain it is risk. And let me see how I answered this part C. In 30 years, there's a higher risk that the interest rates could go up above the rate charged by the bank. Yes?
Would it also be correct to say that like the mean credit value of borrowers that are attracted to a 30-year loan would be probably significantly lower than those that could get approved for a 15-year loan and meet the requirements of a 15-year loan?
That's a good point. Yeah.
Borrowing on 15-year mortgages are much more likely to pay it back than someone borrowing on a 30-year mortgage.
Yeah. So your point is that if someone's borrowing for a 15-year term, the payments are higher, so maybe they have higher income, they have a better credit history. That could be. I think people with poor credit would probably face even worse interest rates than these. Within each loan type, I think there's probably different rates for different credit worthiness, but there could be something to that as well. Okay, so think about risk. Why are auto loan rates higher than mortgage loan rates? Yeah. Exactly right. She hit the nail on the head. So cars lose value over time. We call that depreciation, whereas homes increase in value. And what are those things called? Like the house or the car, as far as the loan? What is it? An asset. When it's securing a loan, we call it collateral. So an asset that secures a loan is collateral. And so if your collateral can be driven around, and if the collateral can be in an accident, or if someone can hide the collateral when you're trying to repossess it, then that's more risk, right? If the thing loses value inherently, then it's more risky, and so that's the primary reason. Now there's lots of other little reasons as well. The term is shorter, so the bank wants to get more of their profits right up front. That may be also a minor factor, but it all boils down to risk. And the same thing comes into play with the credit card. What's the situation with the credit card? There's no collateral. Yeah, think about what type of purchases people make with the credit card. You buy your lunch with the collateral, with the credit card. And so, like the collateral that a bank is going to repossess, you've already digested. Or a trip to Mexico, or a television. I mean, I guess they could send someone to take the television off your wall, but that doesn't happen really often. And so it's more difficult for a bank to repossess the collateral in the case of a credit card. And actually, the way that it's put is that a credit card is an unsecured loan. They can sue you and take you to court, and they maybe are able to garnish your wages, but there's no single item that you pledge to give back to them if you don't pay the loan in the case of a credit card. And so the interest rates are astronomically high. Also because of the convenience of it. So you have to be really careful with credit cards. Okay, so let's talk about different account types. A checking account is sometimes also called a current account, and those are used for frequent withdrawals. I was at the grocery store last week and I saw someone write a check, and that took me back. You don't see checks as much as you used to, but now people usually access their checking account with credit cards rather than, with debit cards rather than checks. Typically you get very little, if any, interest on a checking account, but savings accounts are intended for fewer transactions per month, and a lot of banks have rules that you can only have 5 or 7 transactions a month in and out of a savings account to try and limit the turnover. And you do earn interest, but not very much. A money market account is a hybrid between a checking and a savings account. It's interest-bearing, but oftentimes money market accounts can have checks associated with them. The funds can be withdrawn at any time. And usually the balance requirements are higher than a typical checking account would be. And so money market accounts are sometimes associated with investment accounts, like if you have stocks, then the uninvested funds may be in a money market account that checks can be written against. We already talked about a certificate of deposit. Debit cards and credit cards are both plastic, but how they operate is different in some ways. When you spend money off of a debit card, you're spending your money. And if it gets lost and someone uses your debit card, the person is spending your money. Now you can usually get that money back if it's an unauthorized purchase, but I'd rather just not have them spending my money in the first place. Excuse me. A credit card, on the other hand, is a line of credit where each purchase that you make is with the bank's money, and then you have to pay them back on a monthly basis. They'll give you a statement that mentions the minimum amount due, and the minimum amount due is designed to keep you on the hook for a really long time and paying those high interest rates, because you're much more valuable to the bank if you're continually carrying a balance that is earning interest for them each period. So the people who use credit cards wisely are the ones who pay the balance in full every month, and then you don't have to pay any interest. Like if you make a purchase today and then you pay it off each month in full, then there's no interest due on a credit card. They call that float, where you get to use the money for a short period of time for free as long as you pay every month in full. We discussed what a mortgage loan is, and a home equity loan is a little bit similar to a mortgage loan, except for that it's not for the original purchase of the property, but once you either own a home or if you own some of the house. Let's say that your house is worth $100,000 and you still owe $40,000 to the bank. So the difference between those two, the $60,000 difference, is what's called your equity. That's the fraction of the home's value that you don't owe to someone else. And you can take a loan against that equity. And so a home equity loan is where a borrower is going to use the value of their home as security. And so the interest rate for a home equity loan is a lot lower than it would be for a credit card. So sometimes people use home equity loans to buy a car. Sometimes they're used for home improvements, but they don't necessarily have to be. You could take out a home equity loan and go to Las Vegas with that money if you wanted. But the issue is that the ownership of your house is secured as a pledge against repayment of that loan. Any questions about some of this terminology on different account types? In a couple of weeks, we'll also talk about the difference between stocks, bonds, equity instruments and debt instruments when we discuss how large-scale projects are financed. This is more on the consumer side of things, although businesses do often also have these same account types. Okay. Through the semester, I'm going to show you pictures that are really important. And the goal is that when you see this picture, you'll be able to retell a story about it. This is the third semester in a row I'm teaching this particular class. And throughout the semester, I'm going to try and give you as many hints as possible when there's some idea that the previous 2 semesters the students struggled with. This isn't a game. I want you to learn as much as possible, and I'm not intentionally trying to trick anyone, but just it seems like consistently there are some topics that students find a little bit confusing. And so I'll try and point those out whenever I can to give you the warning that maybe you should focus a little bit more on the textbook and really understand it because it's important. So this is one of them. What I'll sometimes do on quizzes or exams, I'll say, here is an image that kind of illustrates a trend. Tell me, what is the trend? And what's the significance of it? And so what this is showing is that when you borrow money, the cumulative amount that's been borrowed here on the horizontal axis has an effect on the interest rate that is charged by whoever's making the loan. And so look at the trend and see what's the rate. If some hypothetical company is borrowing $1 million, it looks like they have to pay 10% interest for that first $1 million that they borrow. That same company borrows $2 million, the interest rate that they pay is virtually unaffected. But for the third $1 million, you can see now this curve is starting to go up. And each successive $1 million, the annual interest rate is increasing. So can you think why that might be the case? Why is it that a bank would demand a higher rate of return from a company as the amount that they've borrowed goes up?
There's a greater risk in giving them.
Risk. I'm really glad she used that word, risk. There's a greater risk. And so why is there a greater risk?
Because if they don't pay it back, it's a much bigger loss.
Okay, it's a bigger loss. Also, think about any particular company. A company has a certain number of clients. It has a certain amount of revenue it did last year. It has projects in the future. It maybe has projections on how much revenue they have coming in this year. So what this curve is showing is that the bank, before they make a loan, they're going to want to see the books of a company. They're going to want to see how much revenue did you have, what were your profits last year. And what that curve starts to tell you is the bank is getting nervous about risk because they sense there is some increased chance you may not be able to repay. And so what this curve looks like to me is the bank isn't worried about loaning $3 million. I mean, they want to make profit, of course, but the risk isn't really increasing from the perspective of the bank until they get into the $4, $5, $6 million range. And then they think maybe there's a greater risk that something could go wrong. Like if one of those projects falls through, they may not be able to make the repayments on the loans and so on. Okay, so we're going to come back to this figure on Friday and expand on it a little bit more. On the back side of the in-class exercise I've given you is 2 more questions, and these are calculation questions, just to kind of reinforce what we did in class last time. But this time, I've introduced a new equation. And I don't want to tell you too much about this equation. We'll get into it in the future. But I'd like you to see if you can kind of pick apart how to use this equation and pick apart the word statements here. And in question 2, we're calculating some future amount that is owed. And question 3, you're solving for an interest rate. Of course, feel free to discuss amongst yourselves. I encourage that during the in-class exercises. All right, let's take a quick look at the solution, make sure we're all on the same page with problem 2. So I think as I was circulating around, it looked like most people correctly identified that P is 85,000. So P here meant present. F means future. Okay, so P is 85,000. The interest rate isn't going to work unless you convert that to a decimal. So if you put I is 9.5 and then put it directly into that formula, it's going to be looking kind of crazy. The future amount would be really off the charts. So you have to convert that annual interest rate because percent means out of 100. So that's what that percentage sign means, is it means divide by 100. Okay, the future is what we're trying to find over the course of 3 years. So 111,599. Who else got that? Okay, good. Now, this formula, F equals P times 1 plus I to the n, that accounts for something called compounding. Maybe some of you are already familiar with compounding. We're going to discuss compounding in more detail in the future, but the first glance of that concept is that when there's compounding, you have to pay interest on the interest. And so the way to look at it is that after 1 year, whoever, I guess that's us that's borrowing the money, at the end of 1 year, we owe 85,000 plus 9.5% of 85,000. That's how much we owe at the end of 1 year. But the end of 2 years, we owe interest on that total amount from the previous. And so each year that you keep going, you have to pay the 9.5% on the original balance and also all of the interest that has accumulated up until then. So we'll go through these compound interest calculations in the future, but I wanted to acknowledge that that's what this formula is meant to do. It's meant to account for compounding interest over time. Any questions about this first one? All right. On question 2, I use the solver on my calculator, but you can also solve it by just algebraically 4250 divided by 3500, and then you take that to the 1/4 power, which leaves you on the right side 1 plus I, and so then I would be 4250 divided by 3500 to the 1/4 power minus 1. And so either way you do it, whether it's the solver in your calculator or algebraically, or you could even do it just by iteration, trial and error, until you happen to randomly guess the correct I value that makes this equation work out. That's essentially what your calculator's doing, is a numerical solution. 4.97%. That's the interest rate for your uncle. Let's talk about cash flow diagrams and what they're for and why we have them. First of all, consider this very simple problem statement. This is about as easy a problem statement as we could write when it comes to time value of money type problems. You borrow $10,000 at 6% compounded annually to be paid back after 5 years. How much must be repaid? And so it's not really lengthy, but we can summarize this unknown, and we can summarize the entire problem graphically in a more succinct way than that text can. And so we can do that using cash flow diagrams. And so let's talk a little bit about some of the standard expectations when you're doing a cash flow diagram. The first thing that we do with these cash flow diagrams is we have to represent time. Time is a horizontal line when we're doing these diagrams, and we have to begin with indicating when is now. And from our perspective, we say that time 0 is the present, or whatever the present is in the context of the problem statement. So even if the problem says in 5 years you're going to borrow money, and then this whole project starts, and like the beginning point is already known to be 5 years in the future, you may need to represent that future point when the entire project kicks off as time 0. It all depends on the context of the on the problem, but the main idea is that we represent time, the passage of time, with these hash marks each period. It's very common for the periods to be years, but there are other time periods. It can be quarterly, it can be monthly, and so don't always assume that 1, 2, 3, 4 is talking about years. It often is, but not always. As much as possible when you're sketching these sorts of things by hand, you kind of want to make the hash marks equally spaced apart. There's limitations on how accurate you can be when you're freehanding things. That's one of the reasons why I suggest that it's a nice idea to do the homework assignments on engineering paper rather than on lined notebook paper. Does anybody have a pad of engineering paper here today? A lot of you do. I see someone here. So for those of you who haven't ever used engineering paper before, this is what it looks like. It's blank on one side, and on the back side of the paper there's these graphs. And the reason why it's on the back is so that you can just faintly see it. But if you photocopy it or take a picture with CAM scanner, these lines don't show up. So like an actual normal graph paper is kind of really a nuisance to look at because all of the lines kind of obscure your writing. But the lines are just faint enough that you can see them. And these are great for cash flow diagrams because now you can draw to scale a little bit more easily. So I really love it if you do your assignment on engineering paper, although it's more expensive than it ought to be. And they charge a lot for engineering paper. And so another approach is just to use normal copy paper, but then to put a piece of graph paper behind it. And then that way you still have like the guidelines there faintly, and maybe it's a little bit cheaper per page. And we engineers are always looking for efficiency, right? All right, so this is the passage of time. So above the line, we're going to be drawing arrows that represent the money that come to you, and below the line, it represents the money that's going out from you, assuming that you're summarizing your perspective. And remember, on the very first class day, we talked about the difference between rate of return and interest rate. The formulas are the same, but whether we use one phrase or the other depends on whose perspective we're considering things from. So in the same way that we have that, where we consider the perspectives, here we have to consider in the problem statement, whose perspective are we sketching? Are we sketching our perspective or the bank's? Because from our perspective, if we borrow $10,000, then that means in year 0, we're getting some money coming to us. And so we would draw that above the line. So from our perspective, you can see that in year 0, which is the present, we've taken out a known amount of $10,000. The fact that it's a known amount is indicated by the fact that that arrow is solid. It's not a dashed line. You can notice that on year 5, we have a dashed line, and that dash is one of the ways that we can summarize that that's an unknown amount. The other, of course, is these question marks here. That's the other way of us saying this is some unknown amount. But now consider the text versus the sketch. The text you can read, and everybody here is capable of figuring it out, but This, in about half a second, once you get used to reading cash flow diagrams, in about a half a second you can see and instantly understand what kind of problem this is and start to think of how you're going to solve it. So this is just an efficient way to illustrate problems, and especially when they get more complicated. When there's random amounts in various years and there's a lot of moving parts, just the sketch is a nice way to summarize in one place everything that's happening. Whereas a lengthy paragraph of text, you may forget about some aspect of it. The cash flow diagram is just a way to tie it all together in one spot. Okay, one last thing I'll mention is that it's customary to also, somewhere on the sketch, either above or below this horizontal timeline, you also say what's the interest rate. In our case, 6%. Okay, so does this make sense to everybody? Just the idea of visually summarizing the problem statement, the given, the unknown? Any questions about this? So as you might expect, the in-class exercise we're going to work on today is a chance for you to practice this new idea of summarizing problem statements with cash flow diagrams and also interpreting them. A couple other points that I'd like to make. First of all, time can be a little bit confusing for people because the end of year one is right here where the line is that says 1. So this is the first year. The first year starts at 0 and goes to the number 1. So that, I mean, this maybe seems really obvious, but at some point in the semester, probably everybody here is going to have to stop and think, all right, is this the beginning of the year? How much time has passed? You can sometimes need to prove it to yourself that 1 year is from the beginning of this increment, which is the end of the previous year. So take, for instance, from in the second year. The second year is from the end of the first, and so from line 1 to the end of the second year, which is going to be the beginning of the third year. So the customary assumption when we do cash flow diagrams is you assume end of period cash flows. So the end of period cash flow assumption is a little bit like this. If you're operating a business and you're trying to summarize your revenue and your costs on a cash flow diagram, the way to do that is you take all of your revenue and all of your expenses and then you combine them together and represent all of them at the end of the period that they apply to. So if you're doing a month-by-month summary and you're doing a cash flow diagram, then you'd have at the end of this month would be where you'd put the arrow that's associated with the revenue or the costs. So the end of period assumption, you'll get some practice with that, but that's one of the default ways that we handle problems like this is rather than representing at the beginning of the period, it's at the end of the period because, you know, it's the most realistic of the assumptions is that you'll be paid after you do the work. Or when you get a bill, you have some time until you need to pay the bill. Things happen at the end of the periods that they're related to. The other thing that I want to point out is that the scaling, the arrow heights should be, if not scaled precisely, at least larger and smaller. You know, if one of them is meant to be a greater amount, make the arrow larger than the adjacent arrows. It's easier to do scale on the engineering paper, but at the very least you should just make some effort to make the relative size and the relative amount of things clear from the size of the arrows. Now just because a cash flow diagram has a certain number of hash marks on it, the number of hash marks does not imply when you should end the cash flow diagram. So here you can see that we're taking this amount to year 5. We're trying to find out what's the equivalent repayment that's going to be required. You know, if you take a loan of $10,000, how much do you have to pay back in year 5? Well, there happened to be on the cash flow diagram a year 6. And sometimes people can get hung up on like how many marks there are on the cash flow diagram to assume that that's when they're supposed to take the unknown amount to. So if I hadn't, just as an example, if I hadn't put that arrow on there, my past experience says that some people would just assume you're trying to figure out how much is the loan amount in year 6, because that's the end of the cash flow diagram. But really, that's not the end of the cash flow diagram. Time continues indefinitely, we hope. So you basically just have to read the problem statement and take the time to take the amount to the years that are indicated. All right, so these are the labels and the symbology that we use. We've already talked about how interest rate is represented either above or below the cash flow diagram. N is the variable that we assign to the number of periods, whether they be years, months, quarters, whatever the case may be. P means the amount at time 0, and we call that the present, even if it's some future date. It's kind of like the beginning of the project is what's the present from that perspective. F is the amount of money in the future. So in that previous example, P was 10,000, I was 6%, N was 5 years, and F was the unknown. Now it's okay on these sketches to represent it either as a percentage or as a decimal, but you wouldn't just want to say I equals 6. You'd either need to say I equals 6% or I equals 0.06, because you're going to be putting these numbers into equations, and you don't want to have the bad habit of expressing the interest rate as a whole number when really it's a fraction or a decimal. There are problem types that you'll become acquainted with through the semester, and the problem types are often summarized as what you're trying to find. And so sometimes these problems are called present worth problems. And all that means is you're taking some amounts in the future and you're trying to find out how much is it worth today. What is the present worth of these future revenues or future costs? So it's essentially converting, because of the time value of money, converting things into the perspective of the value of money now. So if I said I'd pay you $1,000 in 5 years, how much is that worth today? $1,000 in 5 years. Remember, we've already agreed that money in the future is less valuable because prices are going up, so you can't buy as much stuff with the same amount of dollars in the future as you can now. So if I give you $1,000 in 5 years, the question is, how much of a trade would you be willing to make to have it today instead of waiting in 5 years? Would you take $850 now rather than $1,000 in 5 years? So discounting the future amount to the present is what these present worth problems are all about. Okay? There are also future worth problems where the unknown is some future amount. They're sometimes called future value problems. You're essentially finding out over time how much do the amounts compound. Now, in this previous one, when we were talking about present worth, there was the word discounted cash flow. And the reason why that word discounted is in there is because when you're moving future money backwards in time to the present, the amounts are getting smaller. And so that's a discount. Remember, the idea of $1,000 in 5 years isn't worth as much as that today. And so you'd be taking a discount. So the opposite of discounting is compounding into the future. Finally, we have problem types where we're trying to find a uniform annual amount. And so a uniform series or an annual series are consecutive payments. Consecutive meaning that there's no gaps. They happen year after year with no interruptions, and the amounts are equal. And of course, the end of period assumption also applies for annual worth problems. So these are the 3 problem types that we'll be solving over the next couple of class meetings to account for the time value of money. There's lots of ways to do it. There are formulas. that allow you to calculate this. You may have noticed at the back of your book are these just page after page of interest rate tables. And those interest rate tables are the equations that have been solved for a certain number of years. And so you don't always necessarily have to crunch all the numbers and do all the calculations with the formula yourself. Sometimes there's like a streamlined approach that I'm going to show you how to use. Okay, now you've seen all these definitions before except for those annual worth problems. We just abbreviate that with the letter A. If it's on a cash flow diagram, we'd call that A. Are there any questions so far? Okay, inflow can be the revenues you receive for operating a business, receipts, income. These have a lot of different names. One of the things that is a little bit of a surprise the first time you learn about it, though, is that a cash inflow could also be when you're saving money that you used to spend. So say, for instance, that you have a really inefficient furnace at your house, and right now you're spending $300 a month on fuel oil. If you replace that with a more efficient heat pump, and now your energy costs are only $50 per month, then the savings between what you used to spend and what you have to spend now, the $250 difference between $350, those savings can be considered as a cash inflow. So it's not actually that someone's giving you the money, but compared to the status quo, compared to the baseline condition, you are getting an inflow. Does that make sense to everybody? Savings from a project? Okay, outflows are also known as disbursements or costs, expenses. Those are all interchangeable. They can also be related to the taxes that you incur when you're generating revenue. And we use a minus sign when we're calculating the net cash flow. Net cash flow is the difference between the two. It's the inflows minus the outflows. And hopefully the net cash flow is positive, or else you've got a problem. Revenue minus disbursements is how it's summarized in the text. And remember, the end of period assumption means that we just combine all of our inflows and outflows during a period, and we represent as a single combined amount at the end of that period. You have to be kind of careful, though, because sometimes I'll give you a problem where I tell you a monthly revenue and a monthly expense, and you'll be tempted to just add it all up and express it as one single amount at the end of the year. But if I had given you the interest rate on a monthly basis, then that would be a hint that we're solving this problem with periods being months rather than periods being years. And so my point is, don't aggregate amounts too much. Don't always combine things into years if our periods are months. Okay. Most of the time, when you're solving a problem or when you're drawing a cash flow diagram, you will represent these future amounts as point estimates. And so this is an illustration of how we just assume that we're able to predict with certainty how much our revenues will be in the future. And so this cash flow diagram is saying that each year you have an annual revenue of $150,000. Now, there are certain things that you can predict with absolute guarantee that it's going to be that way, and sometimes there's a lot more risk that the amount could be lower or maybe higher than you expect. And that is when we instead express these cash flow diagrams with a range estimate rather than a point estimate. And so if you want to illustrate the maximum and minimum expected values, what you can instead have is like a range bar. And you maybe have seen error bars before. This is just a bar that shows the expected low and high possibility. And so the purpose of having a range estimate like this is just to kind of consider all the possible cases that could occur. In the end, this course is a lot about decision making and trying to pick which project is better or whether a certain alternative is acceptable. You know, whether you're considering a new server or you're trying to evaluate a piece of equipment that's used in manufacturing. You're going to be spending a lot of money now with the hopes of you can recoup some investment in the future. And you're always maybe tempted to simplify things and say, well, I know it's going to generate a certain amount of revenue 6 years into the future, but it's always better to consider the entire envelope of possibilities. You know, run the numbers with the worst case scenario of that $135,000 per month and see, is the equipment justified at the low end of the range? And then you perform the same estimate to see what would be the present value of this cash flow if it was $150,000. So just kind of approximating the uncertainty is the idea of a range estimate. Okay, I'm going to hand out in-class exercise part 1. What I'd like you to work on is just the front page of this, just a chance for you to sketch some cash flow diagrams. Okay, let's take a quick look at number 1 and see if we're all doing the same thing here. So the problem statement is today you receive $10,000 from the bank, and then starting 1 year from today you make 4 annual payments to the bank in the amount of $3,300. Okay, so you get money today, and today is year 0, and we don't have any information about whose perspective it is, and so we assume that it's our perspective, that we're drawing this not from the bank's point of view, but from ours. So that means that time 0, when we get this money, is a line that's upward, and then you can see that there are 4 downward arrows in the amount of 3,300, and that's an annual series, so that's an A. Any questions about this first one? All right. It can help if you use a straight edge on these. I used a ruler, and just to make sure that the lines are equally spaced. You can see I didn't use an arrow or a ruler on the arrows though. They're a little bit wavy. It's all right. You get the main idea. Okay, let's look at problem 2. Now, this one could be a trick question if you don't catch that it says, draw a cash flow diagram from the bank perspective. So I started off by drawing it from my perspective, and then the bank's perspective is going to be the inverse of that, or the mirror image. So you will save $10,000 at the end of each year. That means you're making a deposit. And I know the word save can be confusing because I've just a few minutes ago talked about if you're saving money because you got a more efficient furnace. This isn't that kind of save. This kind of save is you're making a deposit in the bank. So that's an outflow. Okay, so from your perspective, you're doing an outflow at the end of each year for 6 years. And then in the 7th year, at the end of the 7th year, so here's the first, here's the second, here's the third, and so on. At the end of the 7th year, you withdraw the balance, and the amount is not known. So the dashed line there means it's some unknown amount that we haven't calculated, and we can't calculate because we don't have an interest rate. So that's our perspective, but the bank views it the opposite. The bank views it that, there we go. The bank sees that they have money coming to them at the end of each year, $10,000 at the end of each year, and then at the end of the 7th year, they're going to have some withdrawal. All right, so any questions about that one? All right. Maybe some of you have already flipped over to the back side of the paper. Let's talk about that one. Let's talk about how we sometimes will translate a cash flow diagram into a cash flow table. Excuse me. It's kind of self-explanatory. The only one thing I want to highlight is that sometimes in a given year there will be both an inflow and an outflow. And it's really important that you calculate the net difference between the two. We're going to be doing some procedures later on in the semester where you calculate the interest rate, like where the interest rate is unknown. You'll have a cash flow diagram like this, and it'll say find the interest rate that makes the inflows and the outflows in equilibrium. And if you don't calculate this third column in problems like that, if you don't find the net, then your answer will be slightly off. So this is just kind of some first practice to translate the cash flow diagram into a table. So now we have three different ways that we can summarize problems like these. First, just the text. Second is graphically. And then third, we can summarize these problems tabular, so in a table. So let me give you a moment to write all that in.
Factor in the interest for the present amount?
Good question. The present amount is unknown, and so you just leave that row blank. So we're not actually solving for how much that amount is. You're just translating the cash flow diagram into the table.
Okay.
So the first row will be blank. But this is one that we could solve since we have the interest rate. Okay, the solution to question 3 is up on the screen there. I almost fell into my own trap. That first row represents the present, and we don't have any amount already in the present, and so we can't write any inflow amount or outflow amount. Now, although the interest rate of 8.5% is known, each row is just asking how much is the amount in that year. We're not yet trying to find what's the present value of a certain amount. We just want to find out how much is it in the year that it's received or dispersed. So for instance, this year 2, the $2,000 in year 2, that is a $2,000 inflow amount. Now, in the present, it's not worth $2,000 to us, but in year 2, that was the amount, and so that's why we put it in the table. So you can see that we have inflows every year, outflows on 2 of the years, and then the net cash flow is the difference between the inflow and the outflow. So NCF is in minus out. So it's 2,000, 2,000, then in year 3, it's only 500 because that's the net difference between the inflows and the outflows. Mm-hmm.
Earlier in the slides, I thought we explicitly stated that F was an amount of money that I had in the future, and that any deposit would be represented with, or any money taken out would be represented with a negative number and a D. So if I had 1,500 F, wouldn't that mean I only lost 5? Or is it just an unfortunate choice of letters used? Because F is future money, right?
It means a future amount.
So I have 1,500 in the future.
This 1,500 means that since it's a downward arrow, that's an outflow, right? So it's not that you have it, it's how much you have to pay. All right, so I've got the solution to 4 and 5 up on the screen there. From the bank's perspective, when you receive $25,000 from them, you're getting money, which is an inflow to you, but that's an outflow for them. So they have that downward arrow in the present. So P equals 25,000 in the present, and then in the future you're going to repay them. So their inflow comes in year 3, and F equals 30,000 for that one. Now I got a good question I was walking around, and that is, is that an annual series or is it a single amount? And so in this case, it's a single $30,000 payment that you're going to do in year 3. So some of the clues, if it had said each, then that would be an indicator that it's an annual series, or if it said every year. But otherwise, this is just a single payment. All right, problem 5 I threw out there just kind of as an early taste of what we're going to be getting into next week. I wanted to see how many people would this already make sense for. And if it doesn't make sense for you yet, that's okay, because I'm giving it to you a little bit early. But the idea here on problem 5 is we have some formula that says what is the future amount for a certain present value as a function of the interest rate and the number of years. So we have 2 single inflows that's coming to us that we have to pay back in year 5. And so this $10,000, if you think of it as a loan, the $10,000 we're going to have to pay back interest that accumulates over the course of 1, 2, 3, 4, 5 years. And so 10,000 times 1.06 to the 5 power, because that 10,000 that we get in year 0 is going to be accumulating interest for 5 periods. But the 5,000 that we receive in year 1, that only accumulates interest over 4 periods. And so we have a separate row where we're saying the $5,000 is compounded for 4 years. And so the combined amount is $19,694.